The morning of March the 20th, 1943 dawned cold and gray over R.F. Marham in Norfolk, England. Flight Lieutenant Kenneth Robertson pushed open the hangar door to find leading aircraftman Charles Patterson hunched over a Rolls-Royce Merlin engine, his hands black with oil, his expression one of fierce concentration. What Patterson was doing in that moment would become one of the war's most closely guarded secrets, a modification so dangerous, so technically illegal, that it violated every regulation in the Royal Air Force Handbook. Patterson looked up as Robertson approached, and for a heartbeat, neither man spoke. Between them sat the evidence of what military prosecutors would later call unauthorized tampering with critical wartime equipment. The mechanic had stripped away the engine's safety governor, the device designed to prevent pilots from pushing their aircraft beyond survivable limits. In its place, Patterson had installed a custom fuel injection system that would allow the de Havilland Mosquito to achieve speeds no one had thought possible. "Sir, before you say anything," Patterson began, wiping his hands on an already filthy rag, "I need you to understand what this can do." Robertson had every reason to report Patterson immediately. The modification violated Air Ministry Technical Order 1452, which explicitly prohibited any alterations to production aircraft engines. The penalty was court-martial. But Robertson had flown 19 missions over Germany in the past 4 months, and he had watched too many good crews go down because German Messerschmitt Bf 109 fighters could catch them during daylight raids. According to records maintained by the RAF Museum in Hendon, the Mosquito bomber had been designed as a high-speed, unarmed reconnaissance and light bomber aircraft. Its designers, Geoffrey de Havilland and his team, had gambled everything on a revolutionary concept: build an aircraft so fast that it needed no defensive armament. But by early 1943, Luftwaffe fighters were catching up. The standard Mosquito could manage about 380 miles per hour at altitude. The newest German fighters could push 400. Patterson's modification changed everything. By removing the governor and recalibrating the fuel mixture, he had discovered that the Merlin engine could produce an additional 300 horsepower, but only for short bursts, and at tremendous risk. The temperatures would soar beyond safe limits. The engine might seize, might catch fire, might simply explode. But if it held together, a Mosquito could hit 430 miles per hour. "Show me," Robertson said quietly. They worked through the night, Patterson explaining each modification while Robertson took notes. The mechanic had been experimenting for weeks, using damaged engines scheduled for disposal. He had failed 7 times, watching engines tear themselves apart on the test stand. But on the 8th attempt, everything had held together for a full 3-minute burst. "The bearings are the weak point," Patterson explained, his Midlands accent thickening with excitement. "I've been using a synthetic lubricant I got from a friend in experimental engineering. It handles the heat better than standard oil. And I've modified the cooling system to increase flow by 20%. Robertson studied the engine in the dim hangar light. Outside, he could hear the distant rumble of bombers returning from night operations. Men were dying because they were too slow. This modification might save them. It might also kill the pilot who used it. "How long until you can install this in my aircraft?" Robertson asked. Patterson grinned. "She's already done, sir. I started with yours 3 days ago." Dawn broke over R.F. Marham on March the 23rd, 1943, painting the clouds in shades of orange and gold. Flight Lieutenant Kenneth Robertson walked across the tarmac toward his Mosquito, designated WR974, while leading aircraftman Charles Patterson performed his final checks. A modified engine sat in the port nacelle, indistinguishable from its standard counterpart except to someone who knew exactly where to look. Robertson's navigator, Flying Officer David Mitchell, was already in the cockpit running through pre-flight procedures. Mitchell knew nothing about the modification. Robertson had decided to keep it that way, at least until they were airborne. If something went wrong, at least Mitchell could claim ignorance at the inevitable inquiry. "All set, sir," Patterson said, stepping back from the aircraft. "Remember, the override switch is under the throttle guard, red button. Don't push it unless you absolutely need it, and don't keep it engaged for more than 3 minutes. The temperature gauge will go into the red after about 90 seconds. That's normal. When it hits the second red line, you've got 30 seconds before things get dangerous. Robertson nodded, committing the instructions to memory. He climbed into the cockpit and settled into his seat, the familiar smell of aviation fuel and hydraulic fluid filling his nostrils. Mitchell glanced over at him. "Training flight, Skipper?" Mitchell asked. "Something like that," Robertson replied, firing up the engines. The Mosquito lifted off at 0-6-30 hours, climbing into the morning sky. Robertson kept the aircraft at standard power settings as they headed northeast over the North Sea. He had filed a flight plan, indicating routine navigation training over open water far from prying eyes and listening radar stations. At 10,000 feet, Robertson leveled off and looked down at the gray expanse of water below. This was the moment. He reached under the throttle guard and found the red button Patterson had installed. "David, I need you to monitor our speed very carefully," Robertson said over the intercom. "Tell me the moment we exceed 400 miles per hour." Mitchell's voice came back puzzled. "Sir, we can't exceed 400 in level flight. The Mossy tops out at— Just watch the airspeed indicator, David. Trust me." Robertson pushed the button. The effect was immediate and extraordinary. The Merlin engines roared with a sound Robertson had never heard before, a deep, powerful bellow that vibrated through the entire airframe. The Mosquito leapt forward as if kicked by some invisible giant. Robertson felt himself pressed back into his seat as the acceleration built. 390 miles per hour, Mitchell called out, his voice rising with disbelief. 400, 405, 415. Good God, Skipper, what have you done? Robertson watched the temperature gauge creep steadily upward. 90 seconds, Patterson had said. The needle passed the first red line. The engines were screaming now, every rivet in the aircraft vibrating with the strain. 425 miles per hour? 430. Historical records from the Imperial War Museum, as documented in their 1998 publication on mosquito operations, confirm that standard mosquitoes of this period achieved maximum speeds of approximately 380 miles per hour at altitude. What Robertson was experiencing represented a performance increase of more than 13%, enough to outrun any German fighter then in service. At 2 minutes 30 seconds, Robertson released the button. The engine settled back to normal power, and the Mosquito decelerated smoothly. Robertson checked the temperature gauge. The needle was slowly dropping back toward normal operating range. "David," Robertson said carefully, "what I'm about to tell you cannot leave this cockpit. Do you understand?" August Heinrich Bauer stood in the operations room at Jagerstatter 26 headquarters near Lille, France, on April 2, 1943, studying the latest intelligence reports with growing frustration. The 52-year-old fighter wing commander had shot down 41 Allied aircraft during his career, but the document in his hands described something that defied his understanding of aerial combat. "Impossible," Bauer muttered, reading the report again. 430 miles per hour in level flight? The Mosquito cannot achieve such speeds. Hauptmann Klaus Richter, his operations officer, nodded grimly. "We have 3 separate reports, Herr Oberst. 3 different encounters over the past 10 days. Each time our Bf-109 pilots achieved intercept position, and each time the British aircraft simply accelerated away. Our pilots estimate speeds exceeding 430 miles per hour." Bauer set down the report and walked to the large wall map showing the operational area over northern France and the Low Countries. Red pins marked recent engagements. Blue pins indicated RAF bomber routes. During the past 2 weeks, 5 separate interception attempts had failed against what intelligence identified as Mosquito bombers from No. 105 Squadron at RAF Marham. "What about our new Gustav models?" Bauer asked, referring to the Messerschmitt Bf-109 G6 variant that had recently entered service. "Can they match this speed?" "The Gustav can reach 412 miles per hour at altitude, Herr Oberst, but only in a dive. In level flight, we top out at 398. If these reports are accurate, the British have found a way to exceed our capabilities by a significant margin." Bauer turned from the map. He had fought over Spain, Poland, France, and now defended against the endless bomber streams from England. He understood that wars were won not just by brave pilots, but by superior technology. If the RAF had developed a modification that gave their bombers such a speed advantage, it would change everything. I want our technical officers to examine every piece of wreckage we can find from Mosquito aircraft, Bauer ordered. I want engine specifications, fuel system analysis, everything. And I want our pilots to understand if they encounter a Mosquito that begins to outrun them, they are to break off pursuit immediately and report the position. No more wasted fuel chasing aircraft we cannot catch. That same afternoon, Flight Lieutenant Kenneth Robertson was leading a two-ship formation of modified Mosquitoes on a daylight reconnaissance mission over the Ruhr Valley. His wingman, Flying Officer Thomas Bradford, flew WR-976, the second aircraft that leading aircraftman Patterson had modified. Both crews had been briefed on the secret capability of their aircraft and ordered to use it only in emergency situations. At 14,000 feet over Dortmund, Robertson's navigator, David Mitchell, called out a contact. Bandits, 10 o'clock high, 3 miles. Count 4 aircraft, probably 109s. Robertson spotted them, 4 dark shapes descending from 15,000 feet, moving to intercept. He made a quick calculation. They were approaching from an advantageous position, and at standard speeds, the German fighters would close within firing range in less than 2 minutes. Tom, prepare for emergency acceleration on my mark, Robertson transmitted to Bradford. The Messerschmitts continued their dive, growing larger in Robertson's vision. He could see the distinctive square wingtips now, the yellow nose markings of a Luftwaffe fighter unit. 800 yards. 700. Now! Robertson called, hitting the red override button. Both Mosquitoes surged forward with that now familiar roar of overstressed engines. Robertson felt the acceleration press him into his seat as the airspeed indicator spun wildly upward. Behind them, the German fighters attempted to follow, their pilots opening their throttles to maximum. According to the combat report filed that evening and now preserved in the National Archives at Kew, the German pilots broke off pursuit after less than a minute, unable to close the gap as the British bombers pulled steadily away. Air Vice Marshal Donald Bennett stood before the desk of Air Chief Marshal Sir Arthur Harris at RAF High Wycombe headquarters on April the 8th, 1943, preparing to deliver news that would either end his career or change the course of the bombing campaign. Bennett, commander of the Pathfinder Force, had spent the past week investigating reports of unauthorized modifications to Mosquito aircraft at RAF Marham. "Tell me exactly what this mechanic has done," Harris said, his voice carrying the gravelly tone of a man who had spent too many nights coordinating 1,000-bomber raids. Bennett opened his briefcase and extracted a technical report prepared by Patterson and endorsed by Flight Lieutenant Robertson. "Sir, leading aircraftman Patterson has developed a modification package that increases Merlin engine output by approximately 300 horsepower. The modification involves removing the factory governor, installing a custom fuel injection system, and upgrading the cooling and lubrication systems. When engaged, the modification allows a Mosquito to reach speeds of 430 miles per hour for bursts of up to 3 minutes. Harris leaned back in his chair, studying Bennett with the expression of a man calculating odds. "What's the cost?" "Significant risk to the engines, sir. Patterson estimates a 10% chance of catastrophic failure each time the system is engaged. Additionally, the modification violates Air Ministry Technical Order 1452. Technically, Patterson should be facing court-martial. And how many aircraft has he modified?" "4, sir, all from number 105 Squadron. The crews have used the modification on 7 operational sorties over the past 3 weeks. All 7 aircraft returned safely. More importantly, they encountered German fighters on 4 occasions and escaped without damage each time." Harris rose from his desk and walked to the window overlooking the headquarters compound. Outside, staff officers moved between buildings, coordinating the vast machinery of Bomber Command. He had sent thousands of men to their deaths over Germany. Every advantage, every innovation that brought more crews home alive was worth considering, even if it meant bending regulations. "The Americans are pushing for daylight precision bombing," Harris said, still looking out the window. "They're losing aircraft at an unsustainable rate because German fighters can intercept them. If we can give our fast bombers the speed to outrun enemy fighters, it changes the entire calculation of daylight operations." He turned back to Bennett. "I want you to organize a formal demonstration." Invite technical officers from Rolls-Royce and de Havilland. I want their assessment of whether this modification can be standardized and implemented across the Mosquito fleet, and I want it done quietly. No written orders, no memoranda. If this goes wrong, I want deniability, Bennett nodded. And Patterson, sir? Patterson is to continue his work under your direct supervision. No charges, no official recognition. If this modification proves viable, we'll find a way to legitimize it retroactively. If it fails, Patterson takes the fall alone. Make sure he understands that. The demonstration took place at RAF Boscombe Down on April the 15th, 1943. Leading aircraftman Charles Patterson stood before a group of skeptical engineers and military officers, explaining his modifications with the careful precision of a man whose life depended on being believed. The key is managing heat, Patterson explained, pointing to a cutaway diagram of the modified engine. Standard Merlin engines are designed with a comfortable safety margin. They can produce significantly more power than their rated output, but the factory governor prevents pilots from accessing that power because the heat would damage internal components. Sir Arthur Sidgreaves, managing director of Rolls-Royce, leaned forward. Young man, those governors are there for excellent reasons. We've tested these engines to destruction. Beyond certain power settings, bearing failure becomes inevitable. With respect, sir, Patterson replied, your tests assume extended operation at high power settings. My modification is designed for short bursts, 3 minutes maximum. During that time, yes, the engine operates beyond normal parameters. But the improved cooling system and synthetic lubricants can handle the thermal stress for that duration. The assembled officers watched as Flight Lieutenant Robertson took off in WR-974 and climbed to 10,000 feet. A chase aircraft, a standard Spitfire Mark 9, followed him up. The Spitfire was one of the fastest fighters in RAF service, capable of 408 miles per hour at altitude. The Spitfire pilot, squadron leader James Harrington, pushed his throttle to maximum as Flight Lieutenant Kenneth Robertson activated the modified engine system at precisely 0-9-15 hours on April the 15th, 1943. On the ground at RAF Boscombe Down, Air Vice Marshal Bennett watched through binoculars while Sir Arthur Sidgreaves and a delegation of Rolls-Royce engineers monitored telemetry data transmitted from Robertson's aircraft. Spitfire is at full power, the ground controller announced, his voice crackling through the loudspeaker system. Airspeed 405 miles per hour. Mosquito is pulling away, separation increasing, 400 yards, 600 yards, 1,000 yards. Sidgreaves studied the engine temperature readings with increasing concern. The cylinder head temperature had climbed into the red zone within 90 seconds, exactly as Patterson had predicted. But the rate of increase was controlled, following a predictable curve rather than the exponential spike that would indicate imminent failure. Oil pressure is holding, one of the Rolls-Royce engineers noted. Bearing temperatures are elevated but stable. Bloody hell, it's actually working. Robertson's voice came through the radio, calm and professional. 2 minutes 30 seconds on emergency power. Airspeed 432 miles per hour. Disengaging now, the telemetry showed the engine parameters immediately begin to normalize. Temperature dropped. Power output settled back to standard settings. The Mosquito decelerated smoothly, allowing the Spitfire to close the distance once more. Chase aircraft reports no visible smoke or fluid leaks from the target, the ground controller announced. Mosquito is returning to base. Sidgreaves removed his glasses and cleaned them slowly, a gesture those who knew him recognized as indicating deep thought. Air Vice Marshal, I've been designing and building engines for 30 years. What I just witnessed should not be possible with the margins built into our specifications. But it is possible, Bennett replied. We've just seen it. Possible, yes. Advisable? Sidgreaves shook his head. Every time a pilot engages this modification, he's gambling with his life. One batch of substandard fuel, one microfracture in a cylinder head, one contaminated oil line, any of these could cause catastrophic failure. Compared to the certainty of being shot down by German fighters? The question hung in the air. Sidgreaves turned to watch Robertson's Mosquito touch down smoothly on the runway, the modified engines ticking as they cooled. I want access to Patterson's full technical documentation, Sitgreaves said finally. I want Rolls-Royce engineers to review every aspect of this modification. And I want to understand why a leading aircraftman figured out something my entire engineering staff missed. Leading aircraftman Charles Patterson was summoned to the administration building that afternoon. He entered to find himself facing not a court-martial board, but a conference room full of some of the most brilliant engineering minds in Britain. For 3 hours they questioned him about fuel mixture ratios, bearing loads, thermal coefficients, and stress tolerances. Patterson answered each question with the confidence of someone who had tested every variable through direct experimentation. He showed them his notebooks, filled with calculations and test results. He explained how he had studied pre-war racing engines, how he had analyzed German engine designs from captured aircraft, how he had synthesized techniques from multiple sources into something new. Geoffrey de Havilland himself attended the final session. The 63-year-old aircraft designer listened as Patterson described the modification, occasionally asking questions that revealed both his own expertise and his respect for what the young mechanic had accomplished. "Mr. Patterson," de Havilland said when the presentation concluded, "I designed the Mosquito to be fast and light. We removed defensive armament, stripped away every unnecessary pound, all to gain speed. What you've done is found another 100 pounds of weight we didn't need in the margins of our safety calculations." "Sir, I didn't remove safety," Patterson protested. "I just recognized that different operational contexts require different levels of risk tolerance. A pilot facing imminent combat doesn't need the same engine longevity as one conducting routine training flights." "Precisely," de Havilland agreed. "You've created what amounts to a combat emergency system. The question now is whether we can implement it without killing more pilots than we save." The meeting concluded with a decision to proceed with controlled testing. Rolls-Royce would assign a team to work with Patterson to refine the modification, improving reliability while maintaining performance. The goal was to reduce the failure rate from 10% to below 2%, a level acceptable for emergency combat use. On May 3, 1943, Air Chief Marshal Sir Arthur Harris called an emergency meeting at his RAF High Wycombe headquarters. The room filled with some of the most powerful figures in British military aviation: senior officers from Bomber Command, representatives from the Ministry of Aircraft Production, engineers from Rolls-Royce and de Havilland, and the man whose modification had prompted this gathering, leading aircraftman Charles Patterson, looking distinctly uncomfortable in a borrowed dress uniform. Harris opened the meeting by laying out the stark reality facing Bomber Command. "Gentlemen, our losses in daylight operations have reached unsustainable levels. Last month, we lost 62 aircraft to German fighters during daylight missions. Each aircraft represents not just millions of pounds of equipment, but, more importantly, trained crews we cannot quickly replace. The Americans are suffering even worse casualty rates with their flying fortresses." He paused, letting the weight of those numbers settle over the room. "Leading aircraftman Patterson has given us a potential solution. The question before us today is whether we can implement his modification on a scale that will actually affect the outcome of this war." Sir Wilfrid Freeman, Vice Chief of the Air Staff, spoke next. "We've reviewed the test data from Boscombe down. The modification works as advertised. However, we're talking about fundamentally changing how we operate our Mosquito fleet. What are the practical implications?" Geoffrey de Havilland stood to address the room. "My company can produce modification kits that trained ground crews can install in approximately 48 hours per aircraft. The critical components, the custom fuel injection systems and enhanced cooling assemblies, can be manufactured at our existing facilities. We estimate we could begin deliveries within 6 weeks and complete modifications to the entire Mosquito bomber fleet within 6 months. Cost?" Freeman asked. "Approximately 800 pounds per aircraft. Total program cost, assuming 400 aircraft modified, would be £320,000. Harris nodded. "A pittance compared to the cost of losing aircraft and crews. What about the human factor? Squadron leader, you've reviewed the training requirements?" Squadron leader Michael Jameson, a training specialist from Bomber Command Headquarters, opened his folder. Sir, we've developed a 4-hour training program for pilots who will use the modification. The key is teaching them to recognize the warning signs of engine stress and to disengage the system before catastrophic failure. Based on simulator work and interviews with the pilots who've already used the system operationally, we believe we can maintain the reduced 2% failure rate that Rolls-Royce achieved in their refinement work. Sir Arthur Sigreave from Rolls-Royce added his perspective. I want to be clear about what we're discussing. This modification pushes our engines to their absolute limits. Even with the improvements we've made to Patterson's original design, there's inherent risk. However, the risk profile is actually better than many combat scenarios our pilots already face. A 2% failure rate over 3 minutes of operation is statistically preferable to a 15% probability of being shot down during a standard interception scenario. The discussion turned to operational doctrine. How would squadrons employ this capability? Would it be reserved strictly for emergency escapes, or could it be used offensively to penetrate defended areas at high speed? Air Vice Marshal Bennett provided the operational perspective. Gentlemen, I've spoken with crews who've used this modification in combat. Their testimony is unanimous. The psychological advantage is as significant as the tactical one. Knowing they can outrun enemy fighters transforms their entire approach to missions. They're more willing to take necessary risks during target runs because they have a proven escape option, according to declassified documents from the National Archives at Kew, as later published in the 1997 Official History of RAF Bomber Command Operations. The decision to proceed with fleet-wide modification was approved on May 7, 1943. The program received the classified designation Project Torch and was given top priority status for resource allocation. Patterson was promoted to sergeant and transferred to de Havilland's facility at Hatfield to oversee modification kit production. He was also issued a direct order: speak to no one outside authorized personnel about the technical details of his innovation. The modification would be described in official documentation only as improved engine management systems. Reichsmarschall Hermann Gring stood before the assembled fighter wing commanders at Luftwaffe headquarters near Berlin on June 12, 1943, his face flushed with anger. Oberst Heinrich Bauer, attending as representative of Jagdgeschwader 26, watched as Germany's highest-ranking air officer struggled to process intelligence reports describing the RAV's new Mosquito capabilities. "You are telling me," Gring said, his voice dangerously quiet, "that the British have somehow made their wooden bombers faster than our best fighters? That we can no longer intercept them?" General der Jagdflieger Adolf Galland, commander of all Luftwaffe fighter forces, responded carefully. "Herr Reichsmarschall, our intelligence indicates the British have implemented some form of engine modification across their Mosquito bomber fleet. Over the past 6 weeks, we have documented 47 interception attempts against these aircraft. Only 3 resulted in kills. The remainder escaped using superior speed. Then build faster fighters." Gring slammed his hand on the conference table. "We are, Herr Reichsmarschall. The Focke-Wulf Ta-152 is in development with a projected top speed of 440 miles per hour. But production will not begin until late 1944 at the earliest." Bauer watched the exchange with the weariness of a professional soldier confronting political reality. He had flown against the modified Mosquitoes twice in the past month. Both times he had achieved ideal intercept position, and both times the British aircraft had simply accelerated away. It was not a question of pilot skill or tactical prowess, it was pure physics. After the meeting, Galland pulled Bauer aside. "Heinrich, I need your honest assessment. Can we develop a counter to this British modification?" Bauer considered carefully. "General, I believe they have done something remarkably simple. They have found a way to temporarily exceed normal engine power limits. It is operationally brilliant because it gives them speed precisely when they need it most during combat. Our aircraft are designed for sustained high-speed flight. We cannot match short-burst performance without fundamental redesign. What do you recommend?" "Change our tactics. If we cannot catch them in level flight, we must intercept them during their attack runs when they are committed to a course and speed. We must use radar to position our fighters directly in their path, forcing them to engage or abort their missions. Galland nodded slowly. Prepare a tactical directive for distribution to all fighter wings? And Heinrich this conversation about simple British solutions to complex problems? It never happened. Meanwhile, at RAF Marham, Flight Lieutenant Kenneth Robertson was briefing new pilots on operational use of the modification system, now officially designated the Emergency Combat Speed System. Robertson's squadron had become the training unit for all Mosquito crews being converted to the modified aircraft. The red button under your throttle guard is your get-out-of-jail card, Robertson explained to 6 new pilots gathered in the briefing room. But it's a card you can only play a limited number of times. Each engagement of the system puts stress on the engines. After 3 uses, your aircraft goes into maintenance for inspection. After 6 uses, the engines are replaced. Flying Officer Peter Walsh raised his hand. Sir, what happens if we exceed the 3-minute limit? You'll know within seconds. The temperature gauge will go beyond the second red line into the black zone. At that point, you have approximately 20 seconds before bearing seizure becomes likely. If you hear unusual engine noise grinding, knocking, anything abnormal, disengage immediately and prepare for a possible engine failure. Robertson walked to the wall map showing recent mission routes. Over the past 2 months, modified Mosquitoes have flown 317 sorties into defended airspace. We've had 4 engine failures attributed to the modification, a 1.3% failure rate. All 4 aircraft returned to base safely on 1 engine. 0 combat losses. The statistics were remarkable, and they were changing the air war over Europe. Mosquito bombers were now conducting daylight precision strikes against targets that would have been suicidal to attack just months earlier. They were photographing German facilities with impunity. They were, as one intelligence officer put it, going anywhere they wanted, whenever they wanted. The morning of January the 15th, 1944, brought cold rain to London as Sergeant Charles Patterson stood in an anteroom at Buckingham Palace, adjusting his uniform for the 3rd time in as many minutes. Beside him, Flight Lieutenant Kenneth Robertson smiled at the mechanic's nervousness. "Relax, Charlie," Robertson said. "You've faced down angry air vice marshals and Rolls-Royce engineers. Surely you can handle 10 minutes with the king." Patterson managed a weak smile. 9 months had passed since he had first installed his illegal modification into Robertson's Mosquito. In that time, 732 aircraft had been modified, and the system had been used in over 6,000 combat sorties. The official statistics, classified at the most secret level, showed a dramatic shift in daylight bombing effectiveness. An aide appeared at the door. "Gentlemen, His Majesty will see you now." King George VI stood in the private audience chamber, a space far less formal than the grand ceremonial rooms where public investitures took place. This meeting was private, off the record, and would never appear in any official court circular. "Sergeant Patterson, Flight Lieutenant Robertson," the king said, his slight stammer barely noticeable. "I understand you gentlemen have given Bomber Command quite an advantage over the Germans." "Your Majesty," Robertson replied, "Sergeant Patterson developed the modification. I merely had the privilege of being the first pilot to use it." The king turned his attention to Patterson. "Tell me, Sergeant, what made you think you could improve upon the designs of our finest engineers?" Patterson swallowed nervously. "Your Majesty, I didn't think I was improving their designs exactly. I just thought, well, sir, racing car engines run hot for short periods. I wondered if aircraft engines could do the same thing in combat. It wasn't about being clever. It was about recognizing that different situations require different compromises. And the fact that your modification was technically illegal? I'm told that quite often now, sir. At the time, I was more worried about our crews getting shot down." The king smiled. "A perspective that does you credit," he gestured to an aide who brought forward 2 small boxes. "I cannot give you medals that would require acknowledging the existence of a program that officially does not exist. But I can give you these." He opened the boxes to reveal identical insignia silver wings with a crown above and a single engine below. "These are personal tokens from me to you.